Hold on. All right. Let me explain what happened from then to now. All right. So I did a whole lot. Let me bring out the old commit. Let me go bring out the old one. So this is the third one. Yeah. Can I just switch to it? What do I have currently? I've got this. Just get stash and I'll switch to it. This auto does it for me. Check out. Alright. So what did I have before? So I had a REPL. I did the whole module system, I had a REPL and everything. I didn't have anything to do with the IR, I had nothing. The parser did nothing except have errors and everything. And let me go back to where we are now. Bring checkout to the main. Just bring me back to the head. Bring my stuff back. Alright, now I currently have compiler parsing. So let me run it GCC. Yeah, so let me bring up this file. So yeah, so this is what I have so far, and this is what we got to. This is what we got to before. I think when I started writing the parser, I got up to here. So I only got function declarations, I got type annotations, and I got this like IO form of function declaration. So this is all I ended up with. So I ended up with type parsing, this, function declarations, and this. So before the colons and the equals, you'd usually find a pattern match. I didn't implement that. And after the equals, you'd usually find an expression. I didn't implement that yet. But what I did implement is, between now and then, what I did implement is the IR. And that works perfectly. Yeah, I'll show it right now. Done. So this currently builds it, and then I run it with a.rec, which is just the file extension for now. And then I print out the module. So I'll go into the entry and you can see what I do. Oh, is it main? Yeah. Alright. So here, argc of 1, that means you parse a file or directory, or argc of 2. Right? No, yeah, argc of 1 means it's just this, which means you do REPL. And an argc of 2, which means it can either be a file or directory, it does this stuff. On both sides, you're both setting entry points, you're both parsing, and you get to here. So this is when you return, and then this returns, like, sometimes there's an error, so it sets rval1 and go-tos, breaks out the whole thing. And then you end up with here, dump module. So this dumps the module 0. The modules, the first module is always main, no matter what. And I need to uphold that invariant. So yeah, so IR dump module. And what happens is, here, I'll go over the IR, actually. So what I was doing before, I think you saw this last stream, as a struct mod t. So this is the module, and this is it has a on disk representation, and it has these. So I think I was talking about this as well. So its on disk representation has all of this stuff, like files, name, children, modules and stuff, and that's what we did last stream. But now here, so we have a list of variables, the top level scope, and a list of expressions. So that's basically it. That's all the module is made up with. It's made up with a list of variables, which is either declared and stuff. It has a enclosing top-level scope, and has a list of expressions here. So I can go and count how many expressions we have. We have 1, 2, and 3. And you may think, why does this not count as 3 expressions when it only counts as 1? Well, I merge them together. So if you run multiple definitions with the same variable, it merges them and under different pattern matches. So a single function, let's say you have 3 implementations for a specific function and they have patterns, they all get compiled down into one function with 3 cases on the match. And that makes things a lot easier. That's why I said that this AST isn't really an AST, it's more like a high-level IR, because it doesn't represent the source code entirely. See how it's called it's called an abstract syntax tree? It doesn't represent the syntax entirely. So it's only used as just this intermediate language that I can use. So that's why I didn't say it was like an AST. And I'll show you how the nodes work. So it has a list of top-level expressions, and they're all housed under the scope. I'll show you how scopes work. All the scope is it has its parent, has a pointer to the parent, and it has a list of locals. This is a dynamic array. It has a list of references. So this is just a U32, which indexes into the current module's variables here. And yeah, so let's say you have like a variable at index 0. It's enclosed in a certain scope. You can find its index in that scope, and you can also find it inside the module. So all scopes do is just have a long list of indexes which are variables they own. Yep, so this is the top level scope. So it has like so the scopes have a parent. It always stores the parent. If it's null, it's a top level scope. And everything else. Yep, so you also see variables here. Variables, all they contain is a name, so this is an istr, an interned str, so it's just a U32 index into a arena of strings. So yeah, this is its name, this is its location in the source file. I don't think you've seen this yet. It's just a line number, column, pause, length, and a reference to the file. It's just a U16 index. It used to be a U32 index. I changed it between now and that stream. Yeah, so this is, so there's a module, and so those are the variables. They're just in a list here, and this is the nodes. Here we are. So this is the node. This is the node in this pseudo AST high level IR. So you end up with so this is what I have so far. Like the only expressions actually in use is a proc decal and a integer literal. Yeah. So how it works is these are just the kinds. All nodes have a type because this is all there's like all there's no statements in this language, except for like maybe type decals. This one, yeah, but there's no expressions. Like a function declaration is an expression which evaluates the unit type or void. So yeah, you'll end up with these as expressions. So node proc decal, which references here. So proc decal name and scope. Yep, so the functions have their own enclosing scope. So if you define a variable inside like here, it'll have the scope inside this thing. I would obviously want to have different scopes per invocation, which that's fine, because I can do that with each match case has their own scope. So with every function, there's a list of patterns and there's a list of expressions. There's one pattern per function and one expression per function. So let's say you have a single function, it has 3 different implementations. There's one expression, and one match, and one match, and one match. They all equal the exact same length. And that's how all this works. So what it would do is, here, let me go to the parser and see how this works. P entry. Yeah, so P top statement, it'll go here. I have no top level statements. I'll have to include something like an import statement and everything. But other than that, I have these things. So we're just, this calls into a P statement. So it has an expression which is passes in, and it has a set. So there's no optionals. I would love if we had like optionals in C, but not yet. So I just have to like return a bool and pass as a pointer. Yeah, so this is MP statement, and you've seen this one before. Last stream we ended up with talk.io and talk.ident, so we have multiple different ways to parse. So there's two different types to parse a function, and then other than that, you end up with type decal here, and then last you have expression. So we ended up with this last stream. I just changed it a little bit, and I'll go into the pproc right now. This is for parsing a proc, a function. Yeah, I'll have the source code side by side. So if p.token.kind equals talk.io, so I'll go here, and then it'll go move to the next one, and set is io. It'll check if the current token, so let's say this current token is an identifier. If it's not, it'll raise an error. So this just asserts that it is an identifier. It'll move on to the next one, and check either if it's this, or name to this. Check if this. Yeah, so it'll be here. So name is this, io name equals this. So remember, an io function has no patterns. That's something that I decided on as well. Yeah, that's something I decided on as well. So these io, it makes sense because it's not really a pure function if it accepts no arguments and returns a value. That means it has to influence the state at some point. So this is that's it. Yeah, so if it's not an io function and the token is a colon, it just iterates to the next token, so right after this, and starts parsing a pattern. I haven't parsed the pattern yet, so it just doesn't do anything. And then there's a sequence point that they all reach an assignment. So yeah, so they all reach pattern. Yeah, so they all end up reaching this equals symbol. And I just have some placeholders for now. So I have a node, which is the expression. So that's just a kind. It's a node integer literal. The type is inferred, and it's an integer literal of it's just 999. And here an IR pattern. This is just the pattern kind is a pattern underscore. So like let's say you want to you have like a tuple and you want to match this and forget that. This is what that is in the pattern. So it also follows a node-like tree here. I'll show you what it is. So it has a pattern variable, pattern underscore, and pattern tuple. So it has location. Yeah, so if it's an underscore, there's no point. If it's a var, it stores the variable in the enclosing scope that it's referencing. And if it's a tuple, it's just like a what's it called? A list of arguments. Yeah, so yeah, we'll end up here. So yeah, type. So the type by default is type infer, but if we have a type thingy here, there's a type decal here, like a type manual thingy. It'll put it here. So if next type name equals name, it'll steal that type and then move on here. So what is this for? Yeah, so IO functions can't have parameters, which means they can't have match expressions. What is it, like pattern matching, which means you can't define an IO function twice. There's no point. So it'll end up with these. So we'll end up with this. So this is a name. So let's say we parse this function. We'll get to here. We have a name with v. If the variable currently exists in the scope, it already did because we parsed this. It'll end up in here. So it'll try and find this node, and then it'll so it'll find this node and append whatever we got to this node. And when we get here, it'll find this node and append whatever we got here to this node. So it'll like coalesce them all together and then return false. If it's its own thing like this g, it'll create a new variable with g. It'll create a new scope for this function to be housed in, and then it'll create a list of expressions and it'll create a list of patterns, and it'll assign those here and return an expression. So, and when it gets to here, if the expression already exists, it will append a new function, like overload thingy to it. So that's how all this works. That's all we have so far. We have function parsing, And that's it. We don't even have expression parsing. So that's what I end up. That's what I want to do. That's what I want to do. So I'll end up with by the end of this thing, I'll have expressions, and I'll have patterns, and that's it. That's all I want to do. So I think I'll just get integer literals. No binary. I think we'll do binary expressions, but I'll get integer literals currently. We'll do that. So where do I want to start? Start by changing the song. Okay. Yeah, so this is just like some dump. So IR dump module, it'll go through all the expressions, dump the node. If it's a proc decal, it'll put this down, and it'll So this just generates this. It'll print the type. It'll go to the function and go through all of the different cases and print them. You go here, all the different cases, print them, and then here, and then here, and here. So it only has one pattern. All right. I'll parse expressions now. So where's px, bro? This is the most important, not even the most important, this is the most interesting thing. Parsing expressions. I learned how to do it a long time ago. What's it called? We use precedence climbing. Precedence climbing is the thing that I use. Here. Yeah, talk assign, so it parses an expression. Alright, assert not reached. So I'll show you how I do it normally. This is what like all compilers do. I mean, if you're not using a parser generator, so if you're not like Haskell, if you're not like C or something, but languages like hobby languages like my one, V uses this as well. I've written multiple compilers and interpreters that use this. It's called precedence climbing. I didn't invent it. It's been out for a long time. I'll show you how it works. All of these work based on precedence. So I'll start by modifying the thing. U8 prec. Yeah, and we'll return a node. All right, and then we'll go here and I'll start assigning. All right, so if you look at this, precedence unknown is 0. Assign, compare this, and you've probably seen this before. Calling has the highest precedence, so that's just a dot expression. Things like this, like a calling, and then indexing, that's the highest. Postfix, this is pretty high precedence. These are quite low precedence. These are very low precedence. Assign has very low precedence because it's right. It's what's it, left associative or right associative? Yeah. So I'll start. I don't really have a good way of explaining it, but I'll just explain it by doing. So we'll end up with this function. Parser top precedence. So this just matches tokens to precedence. So do I have these? So we don't have an as cast. Yeah. Okay. So right now I'm gonna have to pay attention to the way expressions work. So these are the stuff that I don't have an as cast, but I probably have. I have colon casting. I have a prec cast is colon. Let's say you want to do like number colon F64. That's a cast right there. I saw it in the hair language, and like the hair language, like the little rabbit. That was one of the nicer ways to cast, so I like that. Yeah, so I want to add all of these. Comparison equals. I want to just like keep adding, but that's what I ended up on. So comparison equals binary or XOR band add multiply cast prefix postfix and call. And there's also an issue when it comes to function calling as well. Is in this language you can call this. So this is essentially A, B, C. Or is it? Is it like call B with C? Yeah, this is this. So this gets parsed like this, right? And this is just because like it's the carried representation of a function. But I still need to end up parsing that. So I need to get around with that and completing that. Anyway, I'll start parsing this. Toc colon is prec casts. Yeah, so all I'm doing is mapping tokens to integers. And it's order. The order matters a lot. So obviously prec call will have a greater integer value than unknown. So let's talk ball. Oh yeah, this is the I don't think I'm gonna add a binary or in this language. Yeah, I think I read something about it. Where is it? Let me check Twitch. What's going on Twitch? Okay. Where did I define it? In macros, right? I define it in macros. Yeah, so the dot operator is one of them. What else is that? Yeah, so pipe is a left function infix application instead of this. And dot is right function infix application. So I'm gonna have to find out what kind of precedence that is. So this I'm only gonna do simple things. I'm only gonna do binary operations for now. Yeah, so let me add new token. Where's bore? Here it is. Toc pipe. Yeah, so it's pipe now. That's not a binary operator now. I don't think I'm gonna add that as well. Anyway, toc pipe. Because if we have this, why have this, right? Right? Yeah. So I'm removing that. Yeah, so there's no toc bands. Sure, I'll add Zor into the language. There's no bore. In this case, toc pipe. I was trying to bore. I just a set not reached. Actually, it's overthrown error anyway. Okay, equal, not equal, less than, greater than, and or prec compare, and all these assignments. And the default is unknown. So all this does is map tokens to. Oh yeah, let me change the type. Kind. Yeah, all this does is match tokens to their precedence integer. And that's what I do here. Alright, so parser expression. So I switch p token type kind case toc ident. Now what's this? Parse ident. Yeah, so this will find, yeah, so what this does is when it comes across an identifier, that means this you found, yeah, I'll show you how precedence climbing works. So all it works is when you call it, it finds the left hand side of the front of the expression, so it's x plus y. It finds the left hand side and continues like parsing until it's found finds the right hand side. This is such a shitty explanation. Okay, I'll explain it after I'm done. Yeah. Case stock identifier. So right now there's no imports. I should probably do imports. Okay. Yeah, v push id. Okay, there's no need for that. Right. So let's find the right hand side. IR node t is LHS. LHS equals IR. Node t expression. Yeah, so it is, the kind is node. Ident. Oh, there's no that. Is it node var? Yeah, node var. Its location is this. Its type is unknown, so that should be type var. And its var is something. We'll end up finding. What do they name it? Find var, search var. So it takes a scope. Yeah. All right. So it takes in the current scope. It takes in the name. So ptoken.lit. And oh, that's pretty smart. It automatically puts that in. Okay. But I'm not gonna do that. R var t is var. Yeah, and then var equals var. Alright, and on error with pause at the... Oh, okay. No, it should return, like, global symbol. Node var. So, okay, I want to make... When it can't find a variable in its current scope, I assume it to be a global one. So that's what I want to write. So I think I'll add a definition for that in here. Yeah. So this is node var unknown, or var global. Node sim. Yeah, make this symbol. Yeah, okay. I stir t is the sim. So this is a symbol that isn't found yet. So else if it's not found. Here, LHS dot equals type is always type info. Actually, okay, I'll leave this up here. All right, so when you find a variable, you set node var and d var equals this. If you can't find it, it's a d symbol, which means you need to set the p.token let. Yep. And then do I... What is this? Hit p next, and I want to do modules. Yep. All right. Break. Default is nothing. And here, okay. Case talk parent. So it's an open parentheses, which means it has a really high precedence. So we just p next, p expr, in this scope with precedence of 0. Talk integer. All this is yep, fill that in for me. This was a node const. Integer literal. Alright, the literal is that. No literal. Alright. So currently we have identifiers, parentheses, and integers parsing. And so this is the left-hand side of the expression. So when you get to here, so if you have the left-hand side and there's no more tokens, that's the expression. So this is why we have this guard here. Token.kind equals uf. Just return. Return, yeah, left-hand side. This is really good reference if you're writing a AST parser. So while rec less than. Now rename this to key talk rec. It's a lot shorter. Yeah, key.token.kind. All right. Now this handles binary expressions and everything else. So this is here. Yeah, talk is infix. Talk output. Yeah, that's a function call. Here I'll do post increment and post decrement. This is case. Token. Token kind. Okay. Case talk increment deck. Start not reached. All right. Yeah, pause and next. Be next. So these are our expressions when you get here. So let me explain. So this is V. This is your V++. So when you get here, your left-hand side is known to be V, and your right-hand side is known to be a plus plus, right? So we basically isolated the expression here, and we're done. That means we can break out of the function and return the combined post increment node, which has the left-hand side and right-hand side. Well, just the left-hand side. Okay. Yeah, and then what do? We just return, right? Yeah, return. Thank you for loading for me. Yeah, I don't have a postfix node yet. Is it post? Yeah, it's postfix node. Postfix. Construct. Yeah. We postfix, and what contains is the expr. And node t. So it contains a reference to the expression, and what else does it contain? Token t. Okay. I'll make a function that consumes a struct and returns its value. And I just add it here. Make it like call it something like malloc. Yeah, and fill that in. Thank you. Yeah, I'll do this. malloc. No. Yeah, I'll call this memmed up. It's easier. Okay, good. D postfix kind equals token. Yeah, token kind. Okay, that makes sense. So if it's an increment or decrement, it does this. And what does it do here? Non-void function does not return a value in all control paths. No, it seems like it should. Return LHS. But yeah, this is how it's supposed to work. Yeah. Node. Yeah, and then LHS equals that. Yeah, it's been a while since I've done this. Yeah, that makes sense. All right, now let's just stop pausing real quick and see what we get. Let's see. Too few arguments. That's 0. Too few arguments. That's 0. Alright, the session failed, the set not reached. What's the token? Yeah, we'll do error with pause. Token.lock. Unexpected. Alright. Yeah, unexpected colon. Okay. Yeah, it's supposed to do this. It's supposed to do nothing. That's what it's supposed to do. But it is infinite looping, so maybe I'll leave that in for now. Yeah, unexpected colon. Alright, and I'll just do this. Colon this equals 29. Parsing file a.rec, module main, v switch, and then case 29. And then we'll do post increment. Yeah, unexpected plus plus. Where did that come from? Oh yeah. Continue. Right. Oh yeah, here should be break. Exit should be this. Should be go to. Perfect. Core dumped. Where? Oh, because I didn't make a thing for it. Node. Was postfix? Yeah, alright. Okay. Yep, IR dump nodes. Postfix.expr. Okay. No memory name up. Is there no? It's kind. Yeah. And I'll just do kind equals talk ink. Then plus plus negative. Good. There it is, 29 plus plus. Let's make that V, or like G. Yep, set not reached. Gonna add case node var. The var. Give a search for the var. Where is it? Mod p vars var dot name. Okay, so that's the var and case node sim, which should be good. Where does it say failed? Can't find a var. Why not? It's not search var. It's not. No, it's not. It's something else. It's not search var. There's a way that search var uses the name. I need to search var by index. Wait, no, you don't need to search var. It's just from here. What was I thinking? Node.d sim. Alright. Good. Wait, what's it? I8 plus plus? What the fuck? Node sim. Hold on. It's probably an error here. The way up here. Probably setting the wrong variable current. This expression. Yeah. Node symbol. Alright, done. G++. Good. So I'm now parsing postfix. Yeah, I'll make this. Yeah, just blank this all out. Alright, I'll make this a commit. What's my usual commit message? Let's write also. This is stream 4. Import. Start simple expr. Good. Done. So that's postfix. We'll do binary operations now. Okay. So it's integer. Oh yeah. Let me see. Let me see. This thing. 3++. Yeah. If that makes sense. Why is still that? Why is that still an I? An I8? I don't know why that's an I8. Okay, that's a G++, and then I don't know why that turns into var all of a sudden. I don't know why. P next. Oh wait. P expect. Okay. Talk cpar. Okay, I don't know what I was thinking. Like, set not reached. Oh wait. Node equals. Jesus Christ, okay. Yeah, and then I have a plus. It's the double pluses. And the triple pluses. And then let's add a minus in there. Good. Alright. Let me undo the last commit and just push that as well. Add this and put that in there. Let's do binary operations now. Which means I have to edit this helper. Okay, talkx operator list. What else? Here, is infix. So add sub mul div mod assign add mul this. Where's band? Band is not one. Bore is not one. To do bold pipe. So L shift dot and as isn't one of our tokens. Dot is though, and dot has one of the highest ones. But do I want to add that though? Want dot to be separate. That's alright. Talk is infix. This is a macro I can use. Where's it? Expr. I got lost. Alright, defaults. So if current token is an infix, This just handles everything. Token.comment. Oh wow, you're shorting them for me. ptalk prac. P next. Yeah, that makes sense. Wow, Copilot's pretty good, filling in exactly what I'm thinking. Other than that, though, it fucking sucks. Node. Yeah, I don't want bin up. I don't like that. Just for infix. Yeah, infix. Yeah. Kinds. Token not kinds. Yeah, seems good. Memmed up node currently, and right hand side equals node. Continue. Else, go to exit. Be done here. Good. That's tested. A plus 10. Obviously that won't work because I didn't write a way to print it, so let's do that now. Node infix. Did you mean node ini fx? Okay, that's wrong. Alright, do that for me. LHS. How do they print them? Or is it util? Print them. PIR prefix. Talk literal representation. Oh, this is nice. Nice. Alright, switch talk. Write a list. Should not return a value. Case printf lit. Invalid conversion specifier equals. What's this? 7 enumeration values not handled in switch. Talk ident. Up literal. Default. So not reached. What is invalid conversion specifier equals? Why is that happening? Oh wait. Break. Why? Why does that happen? It's assuming it's that. Good. Alright, I dump up literal. Yeah, I wasn't bothered to make it return a... You know what? Fuck it, fine. I'll make it return a const char. Yeah, this will just dump the internal representation. So this is just some macro magic. Return literal. Right. Literal. Just up literal. Yep. Node. Infix. Lines. Alright, this should print the left-hand side and right-hand side of a binary expression. Oh no. Node infix. Yeah, that's a spelling mistake. Alright. This is the original one. V, A plus 20, and this returns A plus 20. Perfect. So that's basically how you parse it. And this works with precedence as well, I'm pretty sure. It does. So this makes sense. Type 2. Yep. Works with precedence. There's no way to test that right now because I'm just printing. But I assume it works because I've done this a million times. Okay, so this is good for now. This is good for now. Let me write a git. You know what? Let me just... Okay, fine. Unstage everything. Bring back the old one. Just integrate the new one. I don't want to make a cluttered history. Import base expr. Alright, let's do pattern matching now. Let's parse pattern matching. Because right now I don't parse anything at all. Alright. Where is it? So this is expressions, type parsing, function parsing, yeah, pattern parsing. So you'll create vars it can't find. So how I have it right now is with this current representation of a function. See here, proc decal. So it has a name, it has a scope, and a list of patterns and a list of expressions, right? That means this scope will share all the variables in here, which is not what I want, right? Imagine you declare something else in here, like do k equals something, right? I don't want it to, I don't want this variable to be shared across these, which means I need separate scopes for the separate invocations, which means I need this, a pointer to scopes, which means, that's what I'm going to do first. So, IR scope t scopes equals null scopes with a new one. With a new one. So this one's going to be, here. New scope. This is an array. It's a scope pointer. No. Where is it? I don't want it to return a pointer. That's not what I need. So I just scope p. Yeah, scope ptr. And then I'll make a new one, which just returns it's a non-pointer. Okay, and fill that in for me. Good. Alright, new scope s. And then scopes goes to scopes. So there's a list of scopes per each expression in pattern. I need that here as well. Nice sample. Yeah, so I need to parse an expression with the scope above. Scope t. Closing. Yep, so this will mutate it. Just in case, yeah, so closing. So this will go in here, or it'll go here. Scopes, closing. And this in closing, scope. Alright. Yeah, so this means it's a scope per function definition. And now I need to do patterns. So I can do, you know, let me test I'll do patterns now. And we parse a pattern here. Pattern's always null. Okay. Yep, So its enclosing scope also has to reference a pattern as well, because the pattern will end up creating variables because it's binding to them. The expression here, like this p pattern. So define this here. Pass the pattern here with enclosing scope. I would address that. Alright, p pattern. So currently all I have right now, so I want this to be general purpose, so let me just write bool function is proc. Right, because obviously if you have, let's say you have a pattern like this, x and y, you would be here in your current expression chain, you'd find out it's a pattern, you'd call it, and the pattern would consume the whole thing, and you only need to call it once. But for a function, it'll have patterns like this, x, y, right? And you don't want the braces, so if it is a proc, it'll assume it'll just keep parsing until here. If not, it'll only parse a single one. Because eventually I want to call this inside case expressions. Okay. So I'll just assert right now that it is a proc, and I'll deal with it later. So, are you fucking kidding me? Hold on. Alright, don't fuck up again. Good. No! Alright. Good. Good. Alright. It'll assert if it's a proc, and then it'll keep parsing. It'll be similar to what we just did. So let me just put that as true. Where is it? PX, bro. So I'll take implementation details from this. So where's this? Yeah. Switch p token dots kinds. So obviously I want to, currently what I want to do right now is underscore and then this. Yes, I want to do this, maybe tuples is what I can do, tuples. Maybe not now. So talk. What's underscore? What's talk undefined? Okay, well that's a dumb name. Where is it? Where's the underscore? Alright, I'll add this. I'll add this to my operators then. That's just an underscore. Talk underscore. Okay. Talk underscore. Yeah, p next. Yeah. You know what? I'll just do this. Do. Yeah, this is easier. Do. While. Does that make sense? It doesn't make sense. Yeah. Oh, what's this? Pattern wildcard. Oh, it's a million errors. Pattern underscore. Alright. Good. X-ray is closing brace. Go on. Sonar reached. Fuck off. Default. Error with pause. Key dot token dot log. And then fill in that for me. Expected pattern. Just do unexpected. It's unexpected. Because I have this in the other one. It's unexpected. Where's parser unexpected? Because I swear we have that. Oh, P unexpected. There it is. Expected pattern. That's good. I'm glad I wrote that. Huh. Okay. No is proc. It'll just parse a singular pattern. So it'll just parse this. Or this. It won't parse this. I'm gonna write extra content for that. Okay. Tuck underscore case tuck ident. Yep. No! It's better be the last time. I think I'm kicking it with my leg. Okay. Alright, no more kicking. Fucking hell. Alright. Tuck idents. Alright, fill that in for me. Tuck colon. Why does it need colon? Ah, because it knows, that's a generic specialization. I'll do that later. A long time, actually. I don't think we'll have generics for a long time. Yeah, tuck ident. So it'll create a new var in the current scope. If it exists. Okay, so what is it called? IR search var. Scope S. Name. IRT. Where's search var? Outs can be null. Outs can be null. That's if you just want to search for it. If sure. This just checks that this exists. Does this already, even IR exists in? No. Okay, this is what I wanted. IR exists in. I'll explain when I've finished this name. Alright, okay, I'll explain. So let's say you have a pattern X, Y, Z, right? But a malformed pattern would be something like this, X, Y, X. It'll parse this, it'll create a new variable. It'll parse this, it'll create a new variable. It'll parse this, it'll search all before variables, and before creating it, and then raise an error. That's what I want to do. IR exists if this var exists in this scope. So, error with parse. Yep. Redefinition of this, SV. Okay. And then IR new var in the current scope. Name type infer on name lock. Does this, what's the error message? Okay, that's a, I can just reuse this. I can just assume that it'll throw anyway. Okay. Name lock. Next. IR new var. This returns an error. Right. IR r var t var equals, and then return IR pattern t. Kind equals pattern var. The var equals var. Good. What else? Case integers, right? Because there's integers, right? Integer. Case integer. There's integers and patterns. Is it integer literal? Integer lit. Paster t. This is integer lit. Yeah, literal. All right. Do not disturb. All right, integer lit. Okay, and then just fill in the rest for me. Oh. Integer literal. It's not 964. Oh yeah, these have locks location as well. It's lock. D. No, where is it? D integer lit. Yeah. D integer lit. Set lock. To name lock. All right, integer. That's fine. P pattern. Okay, well let's pause it. Let's pause these things. Pattern is. I want it to match on a tuple as well. All right. Patterns. Oops. No. Okay. While. Okay, we are currently here. So, you know what? Just fill it in for me. No, fucking moron. Okay, do. P. What is it? P pattern. In this enclosing scope. Yeah, took a rep to that. Yeah. No. Alright. This part is a pattern. Do while token is not able to equal to. Yeah. Yeah, if this is just a while loop. I could just transform this into something else. While okay, if no, there always has to be a pattern. There always has to be a pattern when you have this colon here, so this makes sense. Alright. Okay, patterns. Push this. Okay, and then pattern equals a pattern, and this will be a tuple. So kinds equals pattern tuple. What's this lock? What's this current location? Lock will be its location. I want it to be name lock. Name lock. Yes, it was a kind lock, and then the tuple. Not LMs. It's yeah, I want to make it LMs. Okay. Pattern equals think this seems good enough. Let's test it, and I think we'll get errors. Yeah, here. That's fine. Scopes I. Expected this, expected pattern. Good. Pattern 0 equals 0. Unexpected 0. Where did that come from? P pattern. L token. Yeah, P pattern. Yeah, next. Oh, next. Okay, core dumps. Dump pattern. Yeah, case. Integer literal. What's this? PRI64? Okay. It's a string literal. String. Yeah. Integer literal. What else? Pattern var. Means I need to extract its scope as well. Okay, locate it for me. Wow, nice, it did it for me. Good. And case tuple as well. Case pattern tuple. Good. LMs. Sure. This takes in a scope. V, yeah, that's supposed to be nothing. Equals switch. 0 goes to 0. Okay, and let's define more things. So, can we do a factorial? Not yet. But we can do like a equals a plus 10, 20. IR search var failed. IR dump pattern. Ah, okay. No, that's right, right. It's supposed to be the yeah, scopes. Right? There's a taken it. Yep. Yeah, so no D proc decal scopes. It's but because we made changes to make pattern matches have their own scopes. Alright, let's see it. No, it didn't work. Why? Why did search var fail? Decal scopes I. Decal patterns I. Dump node. I mean, that should make sense. I don't know why it's not finding it. Why is it not finding it? What about here? Pattern. Push pattern. Patterns S scopes. Close. So we make a new scope which is parent to S. It parses the pattern according to this and parses the expression according to that. Okay, and it's supposed to create variables, doesn't it? Where is it? P pattern. IR new var scope S type infer on error name lock. Yeah, name lock. Okay. Name lock pattern var d var equals var. Sure. I don't see where the issue is. Pattern d var. printf. Okay. Yeah, I'll make it print the scope. I'll do some, I'll make it print the scope. I'll write a function for that. Void ir dump scope. And fill it in. Okay, fine, I'll write it myself. Mod p scope t. That's. Alright. For this sf. For int I equals 0. 0 c equals rlen s dot. I is less than c. Alright. Okay. Mod p dot bars. Let's move var p. Sure. IR dump scope. Wow, it just doesn't even work. What do I do? Where do I dump pattern? Wait, does this not work? Oh, because the scope is empty? How does that? I don't know how that happens. How does that happen? Pattern ending closing scope. Goes into scopes. Does that not work? It's not supposed to be empty. Yeah, I hate this bug. Expr. Closing scope. Where is S used? S is used nowhere. I don't know where this bug's coming from. Parse pattern. Using closing scope. Let me go here. Oh. Oh wow, it doesn't even get to here. What? Why? Why? Why not? Printf here. Let's get to here. Doesn't? Wow. Oh, because of the fucking... Because of bat. When there's an error, I think it doesn't commit all the... What a joke. Okay. Okay, yeah, it does get here. VK is infer. I mean, that works, right? And then it goes to here. dump pattern. So it is here. IR search var pattern d.var. Oh, it's a... Are you fucking kidding me? Fuck this. I'm not searching for shit. I'm searching for the name. That is so dumb. No, I'm pretty sure I let the AI generate that for me as well. So that's my fault. That's my fault. Pattern diva IR var d. What's dummy? Name. What? Oh yeah, this way. Mod p. Mod p. Good. Don't need a dump scope yet. Okay, k goes to k plus 20. I'll match, let me match, let's write add takes in p and q and returns p plus q. Unexpected colon expected pattern. Oh, hold on. Okay. Do while true. If equals comma. Next else break. Good. So function add takes in p and q and returns p plus q, and that goes add equals switch p plus q goes to p plus q. And let's do some overloads. Not overloads, some other matches. So it's just 0 plus q, and then that's p, and then that's 0 plus p, and then there's also 0 plus 0. PQ, 0Q, P0, 0, 0. Wow, I just did it. That's done. Okay. I think that's good for now. It seems short. Usually I go for an hour. I think this is enough time. Enough time spent. Let me annotate it though. Adds takes in an I32 returns an I32. It's the carried representation. Alright, I32, and does that. Alright. What did I do so far? P pattern. Type decal. Integer literal. Okay. Control enter to enter commit on that. What if I just go ahead? Oh, get. Where am I? Head. No, just bring me to main. Why? Why am I in head mode? I don't know Git. Like, I wish I knew it. Okay, good. Someone may know. Parser, and we are in currently string 4. Parse patterns. Yeah, parse patterns and plus div for proc. Okay, this parses patterns. That is surprisingly well. Good. Good. And think, so I'll commit this. Right. And then close, and go to here. So, I mean, here, I'll just recap. I'll recap what we did. So we just did expressions. Here, let me open this. Yeah. Parse pattern, individual scopes per proc. Did we just lose everything we did on the expressions? No, we didn't. Oh, these all got merged. Okay, well, I mean, what a shame. Fuck, I hate Git. But it's the only thing I have. Let me undo last commit. Parse patterns plus expr. Pattern, yeah, expr. Alright, so we just parsed patterns and expressions this stream. So in my own time, I'm probably gonna like bring all the code over to do module systems because I want to get the module systems out of the way. Then I'll do things like dot expressions. I'll also need to do these special expressions as well. So where I said here, like infix application Haskell is the $sign. So I want to make pipe the left function, infix application, and dot as right function, infix application. Because I'm going to be using a UFCS, was it Universal Function Call System? I don't know. dlang uses it, and Zig, not Zig, it's like Nem uses it. Really nice way that I've come to see. It really fits in with the language. So I'm going to add that as well. That means, yeah, I'm going to have to add specific things for that. Also, a really nice, elegant way to, this is what I came up with today. This is a function to find the max of a array of integers, right? It just takes the first value and compares it, and then returns it. A really simple way, in my language, would just be max matching on 0 equals none, which means it'll infer the type as an optional. And then, here, max has, it'll match on the first element, and the rest of the elements will be a slice. So, and then it'll equal 4x in do, and then it'll do a for loop. This will expand into a macro that will execute the body of this closure. And all it does is it executes the closure and passes in the array element. So if I is greater than x, then x equals this. And you see how it's -x? That means it's a mutable variable, right? It's mutable. Changing this value won't change the backing value inside the it won't change the backing value inside the array. If you want to do that, you have to put mut in front of it. That means you could, if you change it, it'll change it like as it's a pointer into the array, like a mutable reference. But this is just basically setting like an integer value, and just that it's mutable. So you can do imperative programming in mutable stuff, as long as it doesn't escape. It's still a pure function, which means like, I mean, this is great. This is I really like how terse this is. It makes a lot of sense. It's like writing. It's like imperative programming with superpowers, is what I think this language is going to end up like. So, yeah, I'm just gonna be working on expression parsing and everything. I just wanted to get on stream today. I wanted to get on stream expression parsing and pattern matching. That's the most important thing. Like, just to show people, like how these things work. I just want to show people how these things work, and then I can work on my own time and further on. Just want to get the fundamentals and show people. Who is this? Dopetimist. Hey, do you have your design documents online? No, I don't. Right now, these are just like really messy. It's like the messiest markdown files in the world. Like, I don't know how. I don't know. I'm just spamming everything, so I don't have them online. But when my compiler gets to a specific good enough state, I'll eventually like write a bunch of documentation. I'll make like a literate version of this programming language, and I'll also make it so like there's like automatic docs generation. I'll make like the tooling really nice, the documentation really nice. But until now, I just have a bunch of brain juice in the form of just markdown stuff. So they're not online. But in the future, maybe they will. Yes, this is stream 4. I think I'm going to end it here. Good stream. Goodbye now.